Okay, so can you guys see my screen now?
Sir. Yes, sir.
All right. Okay, so the next one here is digraph on reflexive relation. Okay, so here's just the representation of a digraph. Well, as you can see, if we have four elements, we also have four uh, reflexive ordered pairs. So we have 1, 1, 2, 2, 3, 3, and then 4, 4. Okay, if we have 2, then we also have 2, AA, and then BB. All right. Then we also have symmetric relation. Okay, so again, when we see symmetric relation, if we have the ordered pair xy, then we should also have an ordered pair yx. Okay, so we have this example. Let R is equal to AA, BC, CB, and then BB. So in here, relation R is symmetric. Okay, so let me just explain why. So as you can see, if we have xy, we should also have yx, right? And then here we have variable a as your x, and then another a as your y for AA. And then if you're going to come up with its yx, it is still the same, okay? Which is still, oops, which is still AA. So that is why if it's reflexive ordered pair, then it is also already a symmetric ordered pair. All right, so are we clear on that? So this one is already considered as symmetric ordered pair. So did you guys understand that one? Hello? You guys still listening?
Sir, I don't understand. You said if it is reflexive, then it is symmetric.
Yeah, as long as you have this condition. If you have this ordered pair, then you must also have this ordered pair. And your x here is A, your y here is also A. And if you're going to have a yx, it's still AA, which
Yeah, I
is,
understand for this particular example. But for the first example, that is not symmetric because some of them are not like that.
yeah, that, what example is that?
The first example, this one, yeah.
This one?
For 1, 1, 2, 2, the other one.
This one is actually symmetric also.
No, not for this one. There's another one down there.
This one?
Yeah, this example 2.
We're not there yet. We're still in example number 1. So as you can see, we already have an answer which is not symmetric. Okay, we were still in example number 1, which is this one. Okay, I'm just explaining it step by step on why this AA is already reflexive and then symmetric at the same time. Okay, which is just this one. Okay, and as you can see, for the second ordered pair, we have BC, then we should also have CB. Okay, so this is our X, this is our Y. So just interchange those. We have YX, which is your C, and then BB. Okay, wherein we also have that one in our list of ordered pairs. So we have BC, which is this one, and then we also have CB. Okay, and then this BB is the same with this concept. All right, so simple as that. If you have XY, you should also have YX. Did you guys get it so far?
Yes, sir.
Yes, sir.
All right, so this one's very straightforward. Anyway, let's move on to example number 2. So as you can see, 1, 1, so no problem. But how about 1, 2? Okay, so you should check this one already. So if you have 1, 2, you should also already have 2, 1. Okay, wherein it cannot be found. Okay, it's missing on our list. So that is why this one is not already symmetric. Okay, if there is one ordered pair that doesn't or wasn't able to follow this rule or condition, then that one is not asymmetric anymore. Okay, so you could say that this one is anti-symmetric relation already. Okay, so one ordered pair is already enough. Okay, so you don't need to check everything. Okay, so did you guys get the example number 2?
Yes, sir.
All right, so
Yes,
let's
sir.
move on to the digraph on symmetric relation. So the digraph of asymmetric relation has a directed variable or element v to w and a directed edge w to b. Okay, so it should be vice versa. Okay, so AA and then BB, no problem. I have already explained that one using this one. And then for CB and then BC, so as you can see, if C will go to B, there should be also B going to C. Okay, so it will go back or it mirrored itself. Okay, so the same with this example. If we have so 1 1 2 2 3 3 and 4 4, so no problem on those. But for 2 1, oops, 1 2 no. Okay, so this one is not symmetric. So this one actually is the example number 2. Okay, and then this diagram is the example number 1. Okay. So this is just the representation of a diagram. So as you can see right here, we have 1 4, but there is no line that is going back to the 1 or 4 going to the 1. Okay. So that is why this diagram is not a symmetric relation. Right? So are we clear so far on asymmetric relation?
Yes, sir.
Yes,
All
sir.
right, so let's now move on to the antisymmetric relation. So this one is super easy since we already learned about symmetric relation. So again, we have 1 1, so no problem. But we have here 1 2, wherein it doesn't have 2 1 as another ordered pair. So if that's the case, then this one is already antisymmetric. So this one is actually the same example with this one. So before we just call that one not symmetric because I haven't introduced antisymmetric yet. But since you already know antisymmetric, then just call this one antisymmetric. Okay. So for example number 2, we have here AA, BC, CB, and then DB. So you could see that this one is not antisymmetric because this one is symmetric. Okay. So are we clear so far? For the
Yes,
example
sir.
number 2. How about the others?
Yes, sir.
Here naman, sir.
Okay. All right. So here's the continuation of anti-symmetric relation. So tell whether the following relations are anti-symmetric or no. Okay. So letter A, is this anti-symmetric or not?
Anti, sir.
So this one is anti-symmetric because first of all, it doesn't have a relation to compare with. Okay. So if you have 1 1, let's say 1 2, then that's already good. Okay, this one is already anti-symmetric, but since we don't have those ordered pair, the x and then the y, then this one is not anti-symmetric, or this one is anti-symmetric rather. Okay. How about letter B? Is this anti-symmetric or symmetric?
Not anti-symmetric.
Okay, not,
Symmetric.
so not anti-symmetric or symmetric. So they are just the same. How about letter C?
Anti-symmetric.
Anti. Ay,
Asymmetric.
symmetric po.
this one is anti-symmetric, because as you can see right here, we have 1, 2, but we don't have 2, 1. Right? So this one is anti-symmetric. Right? So are we clear so far regarding with anti-symmetric relation?
Yes, sir.
All right, so I hope the others can also follow. Okay, let's now move on to the transitive relation. Okay, so this one is super easy to understand. So let me just copy this one. Just place it here. This one is very helpful. Okay, so as you can see right here, if we have x, y, and then y, z, okay, we should also have an ordered pair x, z. Okay, so the same with hypothetical syllogism. Okay, so let's take a look on this example number 1. So we have here 1, 1, and then 1, 2. And as you can see, so as you can see, we have here the xy and then the yz. Okay, so y is the same with this one, which is 1, 1. Then we should also have an xz. Okay, so you have to find this xz, which is 1, 2. Okay, so this 1, 2 is the same with this one. Okay, oops. Well, this is only coincidence for this example. Okay, so then as you can see, we're good for this part. We could say that for 1, 1, and 1, 2, it's transitive. But how about the others? So let's check. So we have 1, 3, 1, 4, 2, 2, 2, 3. Right here. So we have 1, 1, and 1, 3. Okay. So we have the x, y, and then we have the yz for the y3. So x, y, and then yz. Oops, yz. Okay. So again, you should have this xz, which is 1, 3, which can also be found on this ordered pair, which is the 1, 3. Okay, so this one is also good as a transitive relation. What else? This 1, 1, and 1, 4. So as you can see, we should have this 1 and then 4, which can also be found on its ordered pair, which is the 1, 4. So we are good up to this point also. Okay, let's check the others. What about 1, 2, and then 2, 2? Okay, so we have x, y, and then y, z. So as you can see, we also have this 1, 2 already. Okay, so x, z is 1, 2, which is this one already. So can you guys follow on how we check step by step this relation as a transitive relation?
Yes, sir.
Yes.
Sir.
All right, so again, if we have this x, y, and then y, z, we should come up with another ordered pair, which is called the x, z. Okay, so I would like you guys to verify the remaining ordered pair, whether they are really a reflexive or a complete transitive, rather, not reflexive, complete transitive relation. So your hint here is actually the last part and then the first part of the ordered pair. So you guys have to check this part, 1, 1, 1, 1 again for 1, 3, and then 1, 1 again for 1, 4, and then 1, 2 for the 2, 2 right here, and then 2, 2 for the 2, 3, and then 2, 2 for the 2, 4, 1, 2 for the 2, 4, 1, 2 for the 2, 3. So you have to check all of those. Okay. So you should arrive with X, Z ordered pair. Okay. Or there should be an ordered pair X, Z on this relation. So, have you guys checked everything already? Almost?
Yes, sir.
All right, to those who are not yet done, so I'll give this one as your self-study assignment, okay, or self-study example rather. Okay, so this one is transitive, okay? So if you have x, y, and then y, z, you should have x, okay? How about example number 2? So as you can see right here, we have BC, and then we have CB. Let me just copy this one. All right, so we have BC as your x, oops, xy, and then we have CB as your yz. Okay, so again, we should have another ordered pair, which is the xz, wherein in here it will form a BB. Okay, an ordered pair BB. So is this BB on this relation or set relation? No, guys?
No,
Okay,
sir.
fine.
Wala po.
So, no, right? So this one is not transitive already, okay? So as long as you can find one ordered pair wherein it wasn't able to apply the transitive rule, then this one is not transitive anymore, right? So are we clear so far with this transitive relation?
Mm,
Any concerns or questions or clarification up to this point?
Na naman po, sir.
All right. Okay, so let's now move on to the examples. So consider the relation less than or equal on this set N. So is the relation reflexive? So let me just put this one. Oops. Where's this one first? Okay, so in here we have a relation x is less than or equal with y. Okay, wherein this one is under an element of natural numbers. Okay, so what are the elements of natural numbers again? Where do we start?
1, 1.
Natural numbers. Is it
We start from
0
0.
or 1?
0, sir.
Okay, so we will start with 0. So 0, 1, 2, and then 3. So we'll just get this limitation. So 0, 1, 2, and 3. So 4 elements only. And then we have this condition. X is less than or equal to y. Okay, so since
Sir,
right
di
here,
ba natural numbers?
yes?
Sir, di ba natural numbers? Hindi
Yes.
maunang 1.
Pakicheck nga. Na-miss out ko
Sir,
eh,
yes,
kasi
mauna pa yung 1. Nakalagay.
so there's no 0.
Yes, sir. Full numbers na po pag may 0, sir.
I see. Sorry for that one. So if it's z plus or integer positive, so 1 and above. But if it's full number, then that's the time that you will include 0. But in natural numbers, it's the same with z plus. You will start with 1 and above. Okay, so we'll just take 1, 2, and 3. So as you can see right here, we have this condition. So if you're going to follow this one, if we have this elements for the ordered pair, x, y is an element of natural numbers. So you can form a relation 1, 1, 1, 2, 1, 3, and then 2, 2, and then 2, 3, and then 3, 3. Okay, so as you can see, we have 1, 2, and 3. So for you to be able to say that this one is reflexive, so we should have 1, 1, 2, 2, and then 3, 3 on this relation, which is correct because we have 1, 1, we have 2, 2, and then we have 3. So that is why this relation under this condition is reflexive. Right? So did you guys get it so far
Yes, sir.
on why this relation is reflexive?
Yes, sir.
Okay, so how about the question, is the relation transitive? Okay, let's say we have still the same relations. We have this 1, 2, 3, 6 elements. Means 6 ordered pair, not elements. Let me just remove the circles. So is this transitive or no?
Transitive.
So this one is also transitive because as you can see right here, we have 1, 1, 1, 2. We also have 1, 2. Okay. 1, 1, I mean 1, 2. This one first. 1, 1. 1, 1, and then 1, 3. We also have 1, 2. 1, 2, and then 2, 2. We also have 1, 2. 1, 2, and then 2, 3. We also have 1, 3. And then 1, 3, and then 3, 3. We also have 1, 3. And then 2, 3, and then 3, 3. We also have 2, 3. Okay. So as you can see, just check every possible ordered pair when it comes to checking transitive. Then you must have that x, z on that relation. Okay. So this one is transitive. How about the next one? So we have another condition here. Consider the relation less than on the set n. So is the relation symmetric? So as you can see, this one is not symmetric anymore because we will never arrive at 3, 3, and then 4, 4. Right? Since we have this condition, or we have to follow this condition. Okay. Oops. That one is for reflexive. Sorry, this one is symmetric. Okay. So you will never get a 4, 3 rather. Sorry. You will never have a 4, 3 condition because your first ordered pair or first coordinate is always lesser than the second coordinate. Okay. So are we good so far for this symmetric?
So
All right.
Yes,
How about
sir.
the last one? Antisymmetric. Okay. So as you can see, same condition, same example, or same elements. Okay. So if it's not symmetric, then as usual, this one is already anti-symmetric. Okay, because we will never arrive at 40. Okay. All right. So I hope those examples are super clear on you guys. So let's now move on to the order relations. So we have two parts under order relations. So we have partial order and then the equivalence order. So for now, we'll talk about partial order. So when we see partial order, so this is an order or a condition wherein it met the certain relation wherein it should be reflexive, it should be antisymmetric, and then transitive at the same time. Okay, if there is one relation that is not met on a particular, let's say, example, then that one is not already a partial order. Okay, so you should have these three condition or these three relations. Okay, reflexive, antisymmetric, and then transitive. So for you to be able to say that this one is partial order, just say
Nasa
rat.
mo tayo sa computer.
So you can actually, oops. So you can actually just say if this one is partial order, then it should be equal with rat. Okay. So what is this rat? So it's reflexive, antisymmetric, and then transitive. Okay, so I just come up with this rat for you to have an easier way of memorizing the conditions or the relations. Okay, R for reflexive, A for antisymmetric, and then T for transitive. All right, so let's have an example. So prove that the relation are defined on the Z plus. Okay, so Z plus again is 1 and above by this condition, X divides Y, wherein you will have a result of even, okay, is a partial order. So we should check whether this relation or partial set relation is really a partial order. All right, so let me just copy this one. So again, we'll just use 3 elements for the Z plus. Okay, so this one is positive integer. So we'll just get 1, 2, and 3. And then here's our second condition. So we have here X divides Y. Again, this one is Y divided by X. Okay, wherein you should get an even result, or in other words, you should not have a remainder. Okay. All right. So let's check what are the relations under this condition. So 1, 2, is it a relation regarding with this condition?
Can we start from 1, 1?
Yeah, so yes, sorry. So 1, 1. So we can start with 1, 1. So as you can see, this one is already even. How about 1, 2?
1, 2.
So is this part of the relation? This 1, 2?
Yes.
So yes, because again, just follow this condition. So we have 2 divided by 1, which is equal to even, which is 2. Okay. How about 1, 3?
Yes.
Yes, sir.
So how about 2, 1?
No.
Okay.
No, sir.
No, because again, that will become 1 over 2. Okay. How about 2, 2?
Yes, sir.
Yes, sir.
Yes. How about 2, 3?
No, sir.
No, sir.
No. How about 3, 1?
No, sir.
Oh, 3, 2?
No.
All right. How about 3, 3?
Yes.
All right. So we have now formed the relation set under this condition. All right. So all we need to do is check whether this one is reflexive. So again, rat, reflexive, antisymmetric, and then transitive. So is this relation reflexive?
Yes.
So yes. How about antisymmetric? Is this antisymmetric?
No, sir. Symmetric.
No. No.
So this one is symmetric.
Yes.
Yes, sir.
How come that this one is symmetric? So again, if we have xy, we should also have yz, right? If it's symmetric. But in here, we have 1, 2, but we don't have 2, 1.
Oh, we have 1, 2, and we have 2, 2.
Yeah,
And that
but
will give
you
us
don't,
1.
but we don't have 2, 1. Yz. Yx rather.
Yeah, yx. X, Y, Y, Z. Then we should have XZ.
No. That one is for transitive. What I'm asking is the
Oh.
anti-symmetric.
Oh, antisymmetric. Yes, antisymmetric.
All right. So this one is anti-symmetric because we don't have 2, 1. Okay. We have 1, 2, but we don't have 2, 1. We have 1, 3, but we don't have 3, 1. All right. How about
Yes.
transitive?
Yes,
So yes,
transitive.
also. Okay. We have 1, 1, 1, 2. We also have 1, 2. Okay. What else? 1, 2, and then 2, 2. We also have 1, 2, which is this one. Okay. So as you can see, this one is a partial order. So if all of those are yes, then you could say that this one is partial order. Right. Okay, so are we clear so far when it comes to checking on this particular relation?
Yes, sir.
Okay, so just memorize those three: reflexive, antisymmetric, and then transitive. If there is at least one, let's say it's not transitive, this one is not a partial order anymore. Okay, so all of those should be a yes, right? So again, once you're done in understanding all of the past topics that we have just discussed, then you may now proceed in answering the seat break number 3. So here you're going to determine whether its relation defined on the set of positive integers is reflexive, symmetric, antisymmetric, transitive, and or partial order. Okay, so you have to indicate whether this one is symmetric. If it's symmetric, then just put there symmetric. If it's reflexive, then just put the reflexive. And then again, if it's reflexive, antisymmetric, and then transitive, then just put their partial order. Okay?
Or multiple choice yan.
No. Okay, so you will do this one using Microsoft Word or handwritten. Okay, so I want
Okay.
you guys to show the same as like what I did on the past example. This one. Okay. So you have to list all of the possible elements and then the possible ordered pairs or relation set. Okay, and then we have those conditions. All right. So are we clear so far?
Yes, sir.
All right. So let's move on to the order relations. Okay. So suppose that R is a partial order on a set X. So if X and Y is an element of X and either X is less than or equal to Y or Y is less than or equal to X, then X and Y are comparable. Okay. Then vice versa, if we don't have that condition, X, Y, and then YX, then that one is incomparable. Okay. So if every pair of elements in X is comparable, then R is a total order. Okay, so meaning if you have this XY, then you should have YX. Okay, if you don't have one of those, then that one is already not a total order. Well, this one is super easy to understand. Again, just take note on this condition. XY, you should have YX. So this one is actually the same with symmetric. So if it's symmetric, then that one is a total order. Okay. And then we have here the inverse of relation, wherein it's denoted by R raised to -1. Okay. So this one is actually super simple. Okay. If we have 2, 4, you must also have 4, 2. Okay. If you have 2, 6, you must also have 6, 2. And then you have 3, 3, you must also have 3, 3, you should say. 3, 6, you should also have 6, 3, and then 4, 4, 4, 4. Okay, so basically, and it's asking you to have an inverse of relation or r raised to -1, you just have to interchange the x to y and then y to x, which is the same with this example. Okay, so the same with letter B. We have BC, we have CB, we have CB, we have BC. Okay, so are we clear so far regarding with inverse of relation?
Yes, sir.
Yes, sir.
All right, so we will stop here again for now since we don't have enough time. We'll just continue the rest on the part 3.